So this month we are talking about Opencv, which is a C++, well, I guess it started as a C library. It's a C++ library now that supports image processing and some form of graphics processing. Um, Oops, let me start this recording over here. Okay, so Opencv, it's been around for quite some time. And if we go to their homepage, they have, competition going on, obviously lots of activity going on in image processing these days with feature extraction using deep neural nets and other kinds of machine learning on images and sequences of images, otherwise known as video. We're going to be taking a look at Opencv through their tutorials. Opencv is an open source library. It is on GitHub. And it's just Opencv is the org name, and the Opencv repository is the main repository. It has an Apache license, so it can be used in commercial applications. They also point us to, under resources, there's some books. This one is C++, this O'Reilly book talking about Opencv 3. I'm not seeing that at a cursory level there's major differences between Opencv 3 and Opencv 4, which is what I have installed. The Opencv 4 books tend to be more based around Python. There's a Python binding for Opencv, so you can prototype things quickly in Python. Here is that O'Reilly book I mentioned. It's $75, and even the Kindle edition is $50. So even though this book came out in 2017, it's still a premium for what it has to say. So that means something good for that book. Opencv, they generate all their, if we go back here to library, let's just go back to the home page here. Yeah, so they have this tutorials link, which we will look at in a second, but their online documentation is basically generated through Doxygen. So you can see this is basically, except for the tutorial information up here at the top, it's pretty much a reference. It's only as good as the Doxygen comments that are there for a particular API. And if you haven't done any image processing before, you'll see that this is a field that's been going on for some time. They have their own jargon, they have their own terminology, they have their own common acronyms, and that can be a bit of a barrier at first, but with Wikipedia by your hand and Google on the other hand, you can find everything. It may take you to academic papers that may be difficult to penetrate, but it is what it is. So Opencv is divided into modules, which roughly correspond to functions and namespaces. And if you, through this main modules heading, if you go drill into any of these, it basically takes you to a standard Doxygen generated page describing, namespaces, classes, type defs, enumerations, functions, and so on. And sometimes they have more documentation, sometimes they don't. For the things that matter, a type def, do I really need something explaining this type def that the dual quat with a D suffix is a type def for dual quat of double? Pretty straightforward. But as is the case with a lot of open source projects where their Doxygen or their documentation primarily comes from Doxygen, And this is true of LLVM too, and it's not a criticism of these projects, it's just the nature of the beast. It works okay as a reference material, but not as a user guide, which is why that book still has a premium price on it. However, they do have a set of tutorials, and what I did to play with this library on a surface level. This library's been around a long time. It has a huge surface area in terms of its API, has a lot of functionality. There's no way in an introduction presentation I can cover all of that. So what I did as a way for me to get familiar with the library was I put together a little repo, and let's just do it this way. Let's go here, and so I made a repository where I took their tutorials directory from their distribution, and I copied it over into a fresh repo, and I made a VcPkg dependency file to pick up Opencv 4. So here, let me make this font size bigger. So I have a dependency on Opencv 4 for my project, and I've got a little directory structure where I've got my copy of their tutorials and my CMake scripts and my VcPkg manifest file, and I've got their, just for reference in case I need to grab something, I've got their tree checked out of GitHub, and I've got a build folder. So in my build folder, which I've generated using a standard CMake VcPkg combination, we have a video on VcPkg you can watch to find out about that if you're not familiar with VcPkg. VcPkg went and downloaded the source code for Opencv 4 and all of its dependencies, built them all, built a debug and a release configuration, and put them in our build folder in this VcPkg installed directory, x64 Windows. We've got a typical directory structure there: a bin folder, an include folder, a lib folder, share and tools you might not be so familiar with if you're primarily operating under Windows, but that's a common directory structure for packages in Linux. Share is things like shared data files and all that kind of stuff, man pages, etc., documentation. And in our lib folder, we've got all the libraries that VcPkg built for us. And in the debug lib folder, we've got debug versions of all the libraries that VcPkg built for us, which means when we step into a tutorial, we can not only step into the sample code that is the tutorial itself, but we can step into the Opencv implementation should we desire to do that. And you'll notice that these debug libraries, they all end in a D suffix. So in our build system, we somehow are going to have to get the build system understand if I'm building debug, I need to link with the D version of the library, and if I'm building not debug, release or release minimum size, whatever, then I need to use the library that does not end in a D. With VcPkg, we can take care of this by just doing a find package. So when you use VcPkg and CMake together, you configure VcPkg as a tool chain for CMake, and then the tool chain correctly locates the include files and so on down in that built folder where it stashed all the products of downloading all that source code and building it. So we just need to do find package. Now, there's no standard find module for Opencv, so I just wrote one, and all I do is look for the core header file, and this is the header file for the Opencv core module, the module that is the base functionality of everything. And then using that, I can find libraries. I am finding the release library and the debug library. Technically, this is hacked up for Windows only right now because I went .lib. Oh no, I have the it'll search for the .a as well. Okay, so I haven't tried it on Linux, but it should work. And after we've located those static libraries, which were built by VcPkg, we'll create targets, imported targets for each of those libraries, and set up the include directories for the targets so that when we say our executable depends on that target, we pick up the include directory setting automatically. And so just set up for all the libraries that were built for Opencv, built by VcPkg to provide us Opencv. And since these are static libraries, their corresponding other dependencies have already been combined in. At least I haven't needed to, link manually against JPEG or something like that in order to get that resolved. I think they've resolved it all when they built Opencv. So, if we take a look at their tutorials, they've got an introduction section, and this is just basically how to download it, install it, and set it up, which VcPkg already took care of it for us, so we didn't have to do that. But if we look inside here at their mat container, so they view an image as a multi-dimensional matrix. You normally think of an image having width and height, but if you think of the red, the green, and the blue for each pixel as an additional dimension, you can view that as a three-dimensional matrix. But the mat data type in Opencv is the core of accessing images, and they have helper functions that can read images from files into a mat, or take a mat and write it to a file, take a video camera and sample it to get a single image to produce a mat, etc. So it's kind of the core data structure inside Opencv for low-level image manipulation. But what you'll notice is that the modules in Opencv cover quite a bit of ground, so a lot of times you don't have to write an algorithm that operates pixel by pixel yourself in order to achieve some functionality. So either they've got built-in algorithms that you can pass in your own parameters specific to what you're trying to do in order to extract information, features, etc. from an image, or process an image, doing some kind of filtering per pixel on it or whatnot. You can generally use a higher level algorithm to get that done. And there's also, although there's these main modules, they have quite a number of additional modules, and some of these are contributed, some of them are in the core repository. I just got what VcPkg gave me, and I found that all of these tutorials, let's close some of these, let's do it this way so we don't need that open anymore. All of these tutorials, I just grabbed them out of their tutorials folder in their tree and added a little CMake build, and they all linked successfully. Some of them obviously need input images that you have to supply. I didn't capture those in the repo. So the mat container, let's just take a, here we go. So the mat container is a lightweight handle-like object that references a shared pixel storage. So here they've created a mat from reading a file, and then this second mat called B that they make as a copy of A they're sharing the same storage, and now when they do an assignment down here to assign A into C, C is also sharing the storage. So now A, B, and C are all sharing storage. If you need to get a distinct copy, a deep copy, you can use copy2 or clone to get a copy of the image data. So then you can have two distinct copies of the data. Perhaps you want to make a modification to one of the copies and then apply it back to the original one in some kind of mathematical operation. If we take a look at this, so I've got what I did for arranging these tutorials is I made Ide folders. If you're building this using Make on Linux, you won't see this folder structure. You just see these target names. And then I tried to, oh, I've got some unloaded here. Let's try it this way. There it is. I had them unloaded because I was just building a few and I didn't want them all. Core, mat, source file. So pretty much in all their samples, they're going to bring in the CV namespace. Everything in Opencv is in the CV namespace. You won't see it, obviously, within these tutorials if they're doing a using declaration to bring everything in. I can never remember which one's the using declaration and which one's the using definition, but at any rate, if we drill into this mat class, you can see here's all their doxygen around the methods. That's in their Opencv2 core mat.hppp. They've generally got, for each module, they have a single global header that brings in all the declarations for that entire module, so you can just include one file. If you want to try and break it down, I think you can include the individual subfiles. Like if you were just using mat, you could include core/mat.hpp. They're using .hpp for all their C++ headers. So if we run this, and let's just do a breakpoint and run. I think it's spending time loading symbols from the symbol server. Yes. I don't have a dialog to stop it, so we're just going to have to wait a second. Okay, here we go. So if we step into this constructor for mat, it's building a scalar value, and then it's constructing a mat. It's going to call create, and looks to me like this is going to do the allocate. So it just allocated space for the matrix. That stack.cpp, that was the C++ runtime. I just didn't feel like browsing to it. So we've constructed some matrices, print out the information that's held in M. Oh, it was creating a single matrix. Now it's created a different matrix there by overwriting the previous one. So pretty flexible. You don't have to worry about low-level details of pixels, or manually figuring out image formats, or figuring out how to read these files, parse them, all of that is pretty much handled for you in terms of the core functionality in the core module. So let me go back here. Pretty much all of these tutorials, now they're written by different people at different times, and so they're not entirely uniform in their structure, but they're pretty similar. And usually it's, a discussion interspersed with code about how to achieve certain kind of operation, and sometimes, but not all the time, they might list the whole source file at the end. So like for this one, mask operations on matrices is in this file, and this named window business is they have their own little excuse me, GUI layer. It is this Opencv high GUI library, and you'll see that in their samples they include the high GUI.hpp, and I just bring that up because in image processing there is also concept called windowing, and so this named window function here has to do with the GUI and not with windowing in image processing. But you can see here, just IAMRead allows you to read in an image off of disk into a mat, and here they've got a kernel, image processing kernel, that they're going to run over the image as a 2D filter and show the result. So all the kinds of common operations you want to do in terms of image processing are pretty straightforward. Image processing having been around longer than like the computer vision stuff, which is more feature extraction types of things. So if we take a look at, let's go over here, and we take a look at the tutorials for feature extraction. They've got one on feature detection, feature description. Where's the one I'm looking for is, maybe it's in image processing. So in image processing they had, sorry, the conferencing tool is beeping at me. All right. In image processing they have a bunch of subsections, if you will, within the module of, kinds of transformations you could perform on images, and so I followed that structure similarly for how I arrange these things. And some of these transforms, like the Who line transform, the idea is to, it's not a particularly good example, didn't have a nice I thought one of these had a picture showing the results, but basically we can go take a look at this edge extractor. So if you view this matrix of coefficients as a sliding scaling factor that you move around the whole image, you can use that to detect various features, edges, contrasts, high contrast regions of an image that can be used as a way to detect edges. The way people are generally detecting features now is with neural networks, and what Opencv is acting like although Opencv has some neural net stuff in it directly, I think from reading through these tutorials, or skimming them, I didn't read them in detail, it seems like most of what Opencv is providing in terms of neural nets is the ability to bridge to other systems. So you would train a neural net in an external system, capture the trained result, and then you can use Opencv for inferencing. Opencv can also be used for training, but this deep neural net module is primarily targeted at inferencing. So in neural net land, the training is the part where you're providing it all the input data and correcting the mistakes and running the net again and again to improve its discriminatory response. For instance, if it's supposed to recognize cats in images, if it says a giraffe is a cat, you want to train it to not do that again. So that's a long, iterative, and computationally expensive process, but the inferencing is often much cheaper than the training. So that's why they can run those neural net algorithms on your phone, even though your phone is not some kind of supercomputer, because the inferencing part that's running locally on the phone is not as computationally expensive as the training part. So when most people are looking to integrate machine learning into their vision pipeline or their image processing pipeline, they're doing inferencing. And the DNN module in Opencv is oriented towards that. Now, there were some interesting things that I thought was going on with this Calibration 3D module, that you can use it to you show a, let's just take a look. I think this one might have, I'm foiled again, no pictures. Okay, here we go. So this is a calibration pattern that you display to the camera, and then excuse me. You display that calibration pattern to the camera, and then Opencv will, because of its regular structure, be able to extract information about the optics of the camera that shot the image, because it knows that this is a planar grid pattern. So depending on how the grid pattern is distorted, it can infer information about the camera. And by inferring information about the geometry of the lens system in the camera, you can then extract 3D information from the scene that is imaged by the camera, because now you've got the reverse mathematics needed to identify locations in 3D space based on their image as they appear through the camera. So I thought that was pretty interesting. So under image processing, there was quite a lot of tutorials that they had here. These are very standard stock kind of things. For instance, this is dilation. Dilation is when you run a filter over an image and it tends to expand regions. And then erosion is the opposite. So you can, for instance, if you have a poor quality scan of some handwritten material, where even though in the original handwriting the segments are connected, because the scan is poor, they appear as disconnected segments when they are in fact one continuous stroke. So if you can use dilation to fill in those little gaps. It doesn't work for large gaps, obviously, but it also creates a problem if you dilate too much. Now this dot appears to be connected to the cursive letter when it shouldn't be. But dilation, erosion, kind of interesting process to apply to to an image, and from the code, it's really, I mean, this stuff, this is all setting up GUI. It's not until down here where there's just erosion and dilation that we're doing something interesting. And this is getting an element, doing the erode, and then showing the result. So this erode is, it's actually hyperlink into their Doxygen, which is kind of nice when looking at the tutorials online. So taking you into the Doxygen for this, erodes an image by using a specific structuring element. Okay, so we have to understand more about structuring elements. This a factory function looks like that creates one of the specified shape for morphological operations. So they're creating it at a certain size, at a certain location. What's the anchor position within the element? Okay, so when you apply these filters as a matrix of weights over pixels, you have to specify what is considered the center point of the filter. So that's what this is, because they're making it 2 times erosion size in width and height, and then the center is erosion size. So, and running an erosion operation. Same for dilation. Now, if you are interested in image processing but never took any classes on it or anything, there's obviously tons of stuff out on the web now, and obviously textbooks have been made for many, many years, YouTube videos, etc. There is a user forum for Opencv where you can go and ask questions. In my Googling around, I found that there was pretty good participation on Stack Overflow, although you probably want to tag your post with Opencv if they don't have an Opencv specific Stack Overflow type instance. Another common operation on images is histogram equalization. So the idea here for histogram equalization is, here's an input image, here is the histogram of images based on, histogram of pixels based on their intensity. So most of the pixels are falling in this range of intensity, and then what you do is you stretch this curve out as they're showing here, and you spread the distribution of pixels more evenly across the range of intensity. So this image here, the original, appears, it's kind of hard to differentiate between the grass here and the dog, but once we apply histogram equalization on it, the dog stands out much more sharply in contrast to the grass. That's another classic image processing operation. And if you take out like the argument parsing and the file jigamarole and the GUI stuff, it's like one line. This is it. That's the whole thing. I think that's pretty cool, because I have written histogram equalization by hand myself, and it's easier to use a library like this. And if we go back to this and just take a look at this for a second, and why are they able to do that? And the answer is because they've built the right domain abstractions for the domain of image processing. So the fact that this mat type is so readily obtained from a file, right? I didn't even, let's take a look at this flag, I am read color. If set, always convert the image to a 3-channel BGR. That means if this was a grayscale image, it would get expanded to 3 channels of replicated gray. And I don't care if it's a JPEG file, if it's a TIFF file, if it's a Windows BMP, or if it's whatever image file formats were compiled into Opencv, which, if we take a look at what got built for us, I see JPEG, PNG, I see Turbo JPEG, and I see TIFF. So that's a pretty good range of file formats out of the box. I'm not likely to need anything crazier. I mean, TIFF can support 16 bits per pixel, which is pretty exotic. Looks like they have a PNG 16 as well, so they've got PNG compiled for 16 bits per pixel, or 16 bits per channel, sorry. So we've talked before about different libraries, the standard library and so on, and one thing that makes the standard library so powerful and so flexible and applicable to many different situations is that they got the right level of abstractions with the right level of composability. And from looking at Opencv for the domain of image processing, to me it looks like they've got that same generality and flexibility and composability with their mat data type. More examples of histogram equalization. We can take a look at that sample. Image processing, histograms. So even though they only snipped out a function, or a portion of this file rather, basically the main function, for the doxygen, it's not much longer than that. It's just like a comment line and a couple of includes. Let's see. The other nice thing that I found about Opencv is that if we go back here to our main page, let's just go start from the home page again. So this set of core modules, we didn't talk about video I/O. They've got a nice, let's go here, look at the tutorials for video I/O. Not sure where they got that. I don't remember where they got that hidden. Is it? Nope. Okay, here it is. Reading and writing video files is pretty straightforward with Opencv. Getting either a video stream or a still image grab off of a video stream is also pretty easy. They've got this video capture class. So again, isolating you from all the details of how to read and write these video formats, which they are very non-trivial. So handling all that for you makes life so much easier. That means you can focus on what you're trying to do in terms of the processing of the video instead of details of video formats. I found that to be very handy. There's also some code in here, or some examples in here of obtaining information from a camera that has a depth sensor. So if you're familiar with or remember the Kinect for Xbox, this was basically a depth sensor that captured an image of distance to whatever is in the field of view. So instead of it being a color, it's a number that encodes some distance between the camera and whatever was in the scene. And you can use that to extract what they call a pose, for a skeleton figure. That's how the Kinect games all worked, is they took an image of you that was a depth image. Then from the depth image, they would extract a pose based off of a simplified skeleton model of a human being. And then they, I think the Kinect also had a color camera. So it has color and depth, and it can take the color information and display that on screen, or it can extract just what it thinks is your profile and then place you in a scene virtually. There's some functionality here in Opencv for obtaining those depth images and using them in a coherent way, and so I thought that was pretty interesting. There's a framework called OpenNI, which I was not familiar with until I started looking at Opencv, and that appears to be, I haven't investigated it, but OpenNI appears to be a framework for unifying the sensors, whether it's a Kinect or what have you, so you can interoperate with that framework from Opencv, which is probably more useful if you're trying to do something that can be used with a variety of sensors instead of just one specific sensor. Also, another, I don't know what you call it, like not a vertical market, but a subfield, if you will, for GIS imagery. So GIS is a geographic information system. This is usually mapping data, but it's a lot more than maps nowadays. Could be in the energy industry, they use basically a controlled explosion, and then they measure the seismic reflection in the ground with a, what do they call it, a sonophone or something like that? Seismophone, that's what it is. And they get all this data back, and then they basically have a grid of samples, and they need to do processing on it. So a GIS system today is not just traditional cartography, although that's part of it. With this geospatial data abstraction library, another framework for a different subfield, but they have ways to make it interoperate with Opencv. So that tells me that Opencv has a large community of people that have been contributing things to bridge into their specific data formats and bridge into their computational frameworks in the case of neural net bridges. And that's good to see. That means this community is active and continuing to evolve the functionality of Opencv. Now, we mentioned VcPkg earlier. I just did a VcPkg search Opencv, and you can see there's the original. If I specify Opencv with no version, I get 4.5.1. But there's also Opencv2, Opencv3, and if I only want a particular add-on, I can pick that up as well by specifying the add-on. So for instance, as they've configured the core Opencv, it doesn't build FFmpeg, but if I want, I can install an additional package in my VcPkg manifest, depend on that, and pick up the FFmpeg support. All these tutorials for the core modules, I was able to build them just fine. So the core Opencv4, what did I call it? Opencv4 is the one that I picked to depend on. I quit out of the list there, but Opencv4 is the same as the unversioned. It's 4.5.1. But everything that I needed to go through, at least build all these tutorials, was present in what I got from VcPkg. And if I needed something else, I could obviously just add one of these packages and get the libraries. I will warn you that if you're trying this by yourself, that depending on your machine, you will have to wait quite a while for all of OpenCV4 and all of its dependencies to build, because it's going to build debug and release versions. So it's quite a bit of downloading and quite a bit of building. It seemed to go fast on this machine that I'm presenting from, which is my kind of office machine, but I did it as well on my Surface Book, and it took it long enough that I just kind of put the laptop down and watched some TV for a while and waited for it to finish. I was definitely more than 15 minutes worth of solid building, because it's quite a bit of code. But overall, I find it pretty accessible if you're already familiar with image processing and the field. If you are new to image processing, although Opencv is a good way to experiment, I don't think it's the right way to learn this field from scratch, the domain of image processing. There's probably other websites and so on with tutorials and descriptions or books, what have you, that can get you there, and then you can come back to Opencv as a library. Now that you've studied the field, you know how to describe your problem in terms of the jargon of the field and so on, so that if you need to go to the community to get help, you are all on the same page using the same terminology and descriptions, and they can point you into how to do things in Opencv. Now, although Opencv has facilities for extracting abstract geometry from pixel data, that's feature recognition basically, right? Recognizing text, if you run a text recognizer, what you get back is the string of letters, you don't get back pixels. And that takes you into the next realm of processing, which is now that I've got, instead of an image, now I have extracted line segments that exist in some coordinate space. And if I want to do something interesting with those lines, the next thing you want to do is geometric processing, and that's what we will be discussing next month, is applying computational geometry algorithms to geometry instead of images. And as I say, this Opencv is a huge library. It's been around for a while, long enough to have, there were 10 books on the books page. If we go back, look over here, books. 3, 6, 9, 12, 13. Some of these I think are just being mentioned because they are in another language, which is always a good thing. So obviously there's a huge surface area here. What I found was things are pretty browsable, and the only part where you get in trouble is if you try to look at this global namespace CV. My little scroll thumb has already gotten as small as it's going to get, and we're still downloading the page. So there's hundreds of functions and enums and things declared in this global namespace, but that's the only part of their documentation that is just a little bit cumbersome to go through, just because it's the global namespace. It looks to me like over time they have tried to create new functionality in nested namespaces, so the DNN namespace for deep neural networks, it's not very long at all, so it's a little more manageable. Question in the chat was, what to be my geometry in this context? In the case of Opencv, you can run a feature detection algorithm on an image. It produces a list of features that it's detected. So if it's looking for lines, it produces a set of coordinate pairs that are the lines that it found. And those coordinates represent an abstract line as a geometric line, you would then, if you want to do further processing on that in a geometric sense, that's next month's library that we'll be talking about. Does that answer your question? Okay. Another comment is, I think to understand this stuff, I really need to learn the math, and the same applies with graphics and machine learning, etc. Yes. There is no doubt in my mind that in order to really grok this stuff, you have to get the mathematical concepts down. Now, image processing, it's mostly a notation, the matrix notation, and understanding how filters work when expressed as a matrix. We don't have time to go into that now, but it's simply a mathematical shortcut for a computational algorithm, really is all it is. So the trick is understanding how that abstraction turns into the process of detecting edges. And although not difficult, it does require a little bit more thinking about the math than just understanding how the notation works. Somebody once was in a 3D graphics programming forum, and they were like, I don't want to learn all this matrix and vector stuff. This is all just dumb. I just want to code up my game. And we were trying to explain to them that you're going to be ineffective coding at the 3D graphics API level if you don't understand how these mathematics works, because it's all mathematically based. That's all a computer does, is compute math. And they went away, and they came back a little while later, like a month later, and they're like, sorry, you guys were right. I tried to shortcut my way beyond this stuff and take the short path, and I just ended up being more confused. And then I went back and spent some time and learned the math, and it wasn't that hard, but I just had to put some time in to do it. And once I did that, then everything made a lot more sense, and I was able to make progress. So there is a certain amount of like cart before the horse with this stuff. Fortunately, with Opencv, if you can find a tutorial, of which there are many, that does something really close to what you're trying to do, then it's usually not much effort to modify the tutorial and get something that works. It may not be the most efficient, may not be the most elegant, but sometimes it's just a matter of getting something that works. And that can certainly be a very good way to have a learning experience. I mean, when we obtained this stuff with when we obtained Opencv with VcPkg, we were able to get code that we could step into in the debugger. So if I really wanted to know how histogram equalization worked, I can just, oops, I pressed the wrong function key because it's now dark in my office. F12, go to definition. So here's the declaration for that. And oh, it's not quite, it got into it with the debugger, but my little navigate to definition doesn't quite get there. But it's in the image proc module. So if we go into the I haven't looked in here, so I'm just guessing. I'm guessing this is going to have something with histogram in the name. So that was equalize hist is the function, and there it is. They've got, here it is, sorry. So here's the implementation. This all internal implementation guts with some kind of, skip small images thing. I'm not exactly sure. I haven't looked at this. One interesting thing that they're doing is they have a tutorial on this. they have a parallel for mechanism. So here their little example is they're going to compute a Mandelbrot set, which is a very computationally intensive thing. They got a sequential implementation, and they've got a parallel implementation here where they're going to use their parallel for construct, which you give basically a range of coordinates over a mat. So that's what this is here. And then a lambda that operates on a range that is passed into it. And what the parallel for does is takes this larger domain, carves it up into small subpieces, and invokes your lambda on the small subpieces. Using that, you can get all of your cores on your CPU to be processing your algorithm. And they also have, I didn't show it or talk about it, but they have a way to integrate Opencv in with CUDA. And when we talked about CUDA, we said that one of the ways to get your computation described is to record the kernel launches on a stream. And with Opencv, you can build up your image processing pipeline as a sequence of kernels on a stream, and then submit the stream, and then everything will happen and come back to you when the whole pipeline is done. In the chat, this question says, this looks like it was designed with batch processing in mind. Does it work with real-time as well? And the answer is yes. There's examples there where they have real-time processing. Obviously, the amount of processing you can do in real time depends on how much processing power you have available to you and the size of the image. If you're trying to get 60 hertz frame rate, obviously whatever you're doing has to complete in less than 1/60th of a second, and actually has to complete in a shorter amount of time than that, because the processing time is not the total time available to you. It's a fraction of the total time, because after the processing you have to get the process data copied onto the screen or whatnot. There's always some kind of update loop that contains processing but is not entirely devoted to processing. Their interactive examples tend to revolve around things that are processing live video streams. Another question is, does the core utilities use CUDA or GPU under the hood, or is that only available through the CUDA module? It's only available through the CUDA module. They have a GPU mat class. If we go back here, and it's in the, where was that? Here it is. So in this tutorial there, there's an earlier tutorial that produces a similarity metric between an input image and a reference. And okay, so you can see here they have a GPU mat class that corresponds to a mat on the host. So the GPU mat allocates memory for the image in GPU memory, and use this upload to get image data from the host to the GPU. And there's a corresponding download method, or just simply assigning from the GPU mat to a mat will copy the data to the host. And then they're doing these function calls in the CUDA namespace, and those functions, if we take a look at the signature for one, we will see that the input array and the output array here are all GPU mats. So T1 and T2 are both GPU mats, and GS is GPU mat. So this is doing absolute difference between these two images and storing them in GS, but it's doing that as essentially a kernel launch. It launches a CUDA kernel to do that operation. And since we did an operation where the source and destination were both in the device, then that didn't result in any copies back to the host. Do another operation on the device images. And then this local scaler gets the result of running this sum kernel on the resulting image that was on the device. So it runs a kernel on the device that gives back some data to the host. And that's how they're exposing GPU operations. Is you have to code for it explicitly. It's not coming for free just by using the library with an extra flag or something like that. Do we have any other questions? So, the code where I took their tutorials, set it up to use with VcPkg, and set up a CMake build to build all of these, you can get that from GitHub. And why would you want to do that instead of just downloading the source of Opencv yourself? Opencv itself has a CMake build. You could certainly do that. You can build everything in CMake, or everything in Opencv with CMake. That will also give you all the samples and anything that I didn't create a build for, but I created, as you can see, quite a bit. I mean, it's 89 different tutorials, so that is plenty to go through. And this will give you a chance to play with VcPkg. It'll give you a chance to see how a find module in CMake is written. We've gone over this before when we talked about CMake in detail a few months back. This one is really straightforward, and I just used my own little macros here to eliminate some duplication, but other than that, there's nothing magic going on here. And although you won't have the sample data that goes with these tutorials, like the input images and so on, you can easily get those as just individual files out of their GitHub repo. So I thought this was a pretty nice way to explore a new library without having to. I didn't need to read their build documentation for Opencv. All I did was just set it up as a package dependency, look for the library with find file, find path, find library, and then I was off and running, and everything worked, and I could step through stuff in the debugger, and it was a pretty nice experience. So although it's not the complete set of everything in Opencv, that's why you might want to use this repo on GitHub. Again, if you're unfamiliar with VcPkg and how to get that set up, we got a video on our YouTube channel that shows all that. So, I see a question about, do we post public recordings? Yes, we put them up on YouTube. It's linked from the meetup group. Any other questions before we call it a night? You can go on audio or on chat. Okay. Thanks, and we will see you next month.